All right, let's talk about a challenge that pretty much everyone faces these days. We are swimming in data, just absolutely overflowing with it. So, how do we make sense of it all? How do we find the really meaningful groups that are hiding in plain sight? Well, today we're going to break down a super powerful tool that's built for exactly that, cluster analysis. Okay, so just picture this. You've got maybe thousands or even millions of customer records, or patient symptoms, or survey responses. It's just this massive, messy sea of information. Where do you even begin? Trying to find the natural, hidden patterns in all of that can feel, well, pretty much impossible.
But what if you had a tool that could automatically do the sorting for you? That's kind of the big idea behind cluster analysis. You can think of it like a super smart sorting hat for your data. You just feed it all your messy information, and it intelligently groups the similar items together, revealing these structures you probably never even knew were there.
So on paper, what is this thing? Cluster analysis is a statistical method that organizes items into these groups, which we call clusters, and it does it based on how similar they are to each other. The key here is that it's an exploratory technique. That means you use it when you don't already know what the groups are supposed to be. You're basically letting the data speak for itself.
And this makes it a type of what we call unsupervised learning. Now, with supervised learning, you've already got your labeled bins, bills, letters, junk mail, and you're just training a model to sort new stuff into those existing categories. But with unsupervised learning, which is what cluster analysis is, it's more like being handed a totally messy drawer. You don't have any labels. The algorithm itself has to figure out, hey, all these socks seem to belong together, and all these t-shirts should probably go in another pile. It discovers the categories on its own.
Okay, so where does this data sorting hat actually get used out in the real world? Well, it turns out its applications are incredibly valuable, and they pop up in a ton of different fields.
It's a real game changer in a few key areas. For businesses, oh man, it's the holy grail for market segmentation. For scientists and researchers, it's perfect for that initial dive into a new data set. For organizations, it can be a huge help with resource allocation. But it goes way beyond that. We're talking about everything from healthcare, where you could link certain neighborhoods to illnesses, to HR, where you could find groups of employees who feel the same way about the company culture.
Theory is great, but to really get how this works, let's just walk through a story. We're going to follow an online bookstore that used cluster analysis to understand its customers better and, to sell more books.
So first things first, they set a really clear goal. They wanted to use personalized recommendations to boost sales. Simple enough. They decided to focus on two key data points they had for each customer: their favorite genre and how much they typically spend. Now, this is the clever part. Since genre is a category, like sci-fi or romance, and spend is a number, they used two different methods that were perfect for each data type. Then they hit go on the algorithms, telling them to find three distinct groups.
But here's the thing. Just running the analysis is only the beginning. The really crucial work came next. They had to validate the results, to make sure the groups were actually meaningful and not just random. Then they had to interpret them. They had to look at each cluster and ask, okay, who is this person? What's their story? And finally, they could put those insights into action by creating marketing campaigns that spoke directly to each of those new customer profiles.
And here is the amazing result. Look at this. They didn't just have data anymore. They had these super clear, actionable customer segments. Cluster 1 turned out to be the sci-fi fans who don't spend a lot, so they started getting alerts about new releases. Cluster 2 was the mid-range romance readers. They get author spotlights. And Cluster 3, the mystery lovers who spend big, they get exclusive offers for premium editions. That's what it's all about, turning raw numbers into a real strategy.
So, the bookstore made that look pretty straightforward, right? But how does that sorting hat actually work its magic? Let's take a quick peek under the hood at what the algorithm is really doing.
So remember, the bookstore used k-means and k-metoids. Here's the difference. K-means finds the center of a group by basically calculating the average of all its data points. This creates a kind of theoretical center, called a centroid. It's awesome for numerical data, like how much money people spend. K-metoids, on the other hand, does something different. It picks an actual data point from within the group to be its center, or metoid. This little trick makes it much better for categorical data, like someone's favorite genre, and less sensitive to weird outliers.
But no matter which fancy algorithm you use, k-means, k-metoids, or any of the others, the main objective is always the same. You want to create groups that are really tight on the inside and really well separated from each other on the outside. It's all about measuring distance.
And you basically measure success here in two key ways. First is intra-cluster distance. That's the distance between points inside the same group. You want that distance to be as low as possible. That means everyone in the group is super similar. The second is inter-cluster distance. That's the distance between the different groups. You want that to be as high as possible. That means your groups are very distinct and different from one another. Low on the inside, high on the outside. Get that right, and you've nailed it.
Okay, so now that we've dug into the how a little bit, let's pull back and look at the big picture again. That bookstore example was great, but the real power of cluster analysis is just how incredibly versatile it is. It's used in completely different worlds.
I mean, think about it. In medicine, you can group patients by their symptoms to find new diagnostic patterns. In education, it can help identify groups of students who need a specific type of support. And in biology, it's literally a cornerstone of how we classify life, grouping species together based on their shared traits. The same core idea applies everywhere. Find the hidden structure in the data.
So it really all boils down to this. Cluster analysis is a fundamental tool for discovery. It takes all that messy, chaotic data and transforms it into meaningful, actionable groups. It does this by finding subjects that are so similar to each other that their shared traits become a unique characteristic, setting them apart from everybody else.
And that really brings us to the final question, the one for you to think about. Whether you're a marketer, a scientist, a researcher, or really just anyone who's curious about the world, the patterns are out there, waiting. So the only question left is, what hidden groups are just waiting to be discovered in your data?